Hi everyone, myself Hamsa. I am studying in Sri Venkateshwara College of Engineering in Mechanical Engineering under Visvesvaraya Technological University. Today I am going to give a technical seminar on the topic called Machine Learning in Material Science. This is a simple figure of machine learning in material science. This involves the best practices of dissemination and availability, materials property data, data processing and feature engineering, and machine learning. It takes the material properties data and it processes the data, and by using feature engineering, it is modeled by using machine learning. Next, let's move on to the introduction to machine learning. Machine learning is defined as the capability of a machine to initiate intelligent human behavior. So machine learning means we are going to deal with the machines. We are going to interact with the machines. Machine learning is defined as the capability or the capacity of the machine to behave with human intelligence. Means if we want to interact with the machines, we use a machine learning language or high level language. I will give you an best example. If you want to communicate with other person, how would you communicate? By using language. The language is the basic thing to communicate with another person. In the same way, if we want to communicate with the machines, we need a language, that is high level language and machine learning language, low level language. Like that, many languages are there. For example, Python, C++, Java, etc. Machine learning is a branch of artificial intelligence which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improve its accuracy. By using machine learning, we can get more accurate results. And it uses the data and algorithms. The data is provided by the human. And machine learning is a application of artificial intelligence. See, you can see this picture, the human and the machine. Human tells that he can learn everything automatically from experiences. Can you learn? Then machine says that machine can also learn from past data with the help of machine learning. So machine needs a past data, but human doesn't need the past data. Human learn everything automatically from his experiences. So machine learning need a data which is provided by the human. Material science. Let's move on to the introduction to material science. Material science is an interdisciplinary field of researching and discovering materials. It is an interdisciplinary field. Why we tell that it is an interdisciplinary field? I will give you a best example. If you see in engineering field, there are many branches, like computer science engineering, electronics and communication engineering, mechanical engineering, and civil engineering. In each department, we have different materials. For example, if you take a civil engineering, we have different materials like bricks, sand, and all. If you take in electronics and communication engineering, we see different types of materials like microcontrollers, sensors, which we use in daily life. In the same way, each department and each field has its own materials. So it comes under interdisciplinary field. In all the field we use materials. Materials plays a very important role. So it is an interdisciplinary fields which helps in researching and discovering materials. Material science is the studying the interplay between the structure of materials. In material science, it is one of the field. It is one of the engineering field. We study the structure of materials, the behavior of materials, and interplay between the structure and the materials. You can see the picture. These are all the materials only. In the first picture, you can see it is casting. In the second one, that is molecular structure. That is also comes under material science. And these are all the materials like polymers, ceramics, like that. Next, we move on to the introduction to machine learning in material science. The rapid expansion of material data from experiments, computations, and simulations is exceedingly large. This massive amount of information, this could be due to the large number of samples collected over time through experiments or simulations. It is not only advantageous to have a large data volume, but it can also to be difficult to deal with massive amounts of data. There is a rapid expansion of material data from experiments. For example, if you consider any experiment, we have more data. If there is only 5 or 10 data, then human can deal with that. If it is more than more data, then it is risk for human to compute with the data. So if it is a very big data, then we can interact with this machine learning. By using machine learning, we can solve those problems. As you know that the simulation software and all, before it was offline lab and all, but nowadays we see virtual labs and simulation softwares and all. These simulation software and virtual labs comes under machine learning only. If it has a large data volume, then we can deal with machine learning. We can solve this problem by using machine learning. Machine learning has become an essential part of our daily lives in the age of big data. To deal with the big data, we use machine learning. Traditional modeling and simulation capabilities have been accelerated, enhanced, and completed by ML algorithms. So what is algorithm? Algorithm is a basic step to solve the problems. Algorithm is a steps which is used to solve a problem. Then this modeling and simulations have been done by using ML algorithms only. Because traditional trial and error methods in material research are expensive, material scientists have relied on simulation and modeling method to understand and predict material properties. As you know, the trial and error method is difficult and it's time consuming and it is expensive. In order to prevent the time consuming and expensive, we use machine learning technique like simulation software and all. By using the simulation software and modeling methods, we can reduce the time. Then it is less cost also. And we can predict the material properties. Machine learning can significantly reduce computational costs and shorten the development cycle, make it one of the most efficient methods of replacing humans. So it can reduce the cost also, and it can shorten the time, or it can shorten the period. It is one of the most efficient method of replacing humans. Machine learning, it is a branch of artificial intelligence, uses large amounts of data to continuously optimize models and make reasonable predictions guided by algorithms. As I told earlier, algorithm is a basic step to solve a problem. The reasonable predictions are made by algorithms only. This artificial intelligence uses a large amount of data. The entire machine learning process, including data processing, modeling, and validation, will be covered in detail below. It depicts a basic machine learning workflow. You can see this figure. It is a basic machine learning workflow. Data, training set, algorithm, evaluation, prediction and model, and production data. In this testing data set, we are going to test the data. We are going to do a trial. Let's move on to the data processing. Data processing is the method of collecting raw data and translating it to usable information. Data processing means we are going to get the raw data and we are translate into a usable information. For example, raw data means, I will give you an example. If you go to hospitals or you want to get the blood report, if you want to get the blood report, we will take that blood reports as raw data and we take 100 reports, that is raw data. Then that 100 reports we are going to translate into usable information like patient name and ID. We are only taking the patient name and ID, that is usable information. We are going to orient the data according to our desire. It is usually performed in a step-by-step process by a team of data scientists and data engineers. This data processing can be done by data scientists and data engineers. Data processing is a crucial step in the machine learning as it prepares the data for use in building and training ML models. It is one of the crucial steps in machine learning. The goal of data processing is to clean, transform, and prepare the data in a format that is usable for modeling. The main goal of the data processing is to clean, and it collects the raw data and it translates into a desired usable information which is suitable for modeling. These are all data processing is done by humans. You can see this picture: data collection, data aggregation, data analysis, forecasting, decision, distribution. These are all the steps of data processing. Let's move on to the data selection. Data selection is defined as the process of determining the appropriate data type and source suitable instruments to collect data. Data selection means we are going to select the suitable instruments based on the experiment. If you want to do one experiment, we have to select an instrument, right? To select that instrument, we use data selection. The primary objective of data selection is determining appropriate data type, source, and instruments. For example, for data type, I will give you an example. In hospitals, the blood report. The blood report is a data type, and the source is a blood, and the instrument used is syringe. By using syringe, we are going to take the blood. The source is blood, and the data type is that blood is converted and analyzed to give a blood report. That is the data type. The data for material science can be roughly classified into 4 types. Experiment and simulation derived material properties, that is physical, chemical, structural, thermodynamics, dynamics, etc. These are all the experiment material properties. Data and chemical reactions. This comes under chemistry, that is reaction rate, reaction temperature, etc. Image data. Material scanning, electron microscope images, photos of material surfaces. These are all the image data. Then information from the literature. These data can be discrete, for example, text, continuous, for example, vectors and tensors, or in the form of weighted graphs. It is difficult to consider data from multiple databases because the data is stored in various databases in various formats. As we know, the data, it will be of any type. We can't say exactly it will be in word format only or in image format only. We can't tell. Data can be of any type. For example, vectors and tensors, text, weighted graphs, numbers, etc. Furthermore, the required data format is determined by the machine learning algorithm used. As a result, data must be formatted uniformly, and a suitable data representation must be chosen for machine learning algorithms in data processing. Common data representations include fingerprints, smiles, weighted graphs, and the Coulomb matrix. These are all the examples for data selection. Feature engineering. After data selection, one should extract suitable characteristics for the predicted target, which is called feature engineering. What is feature engineering? Feature engineering means after the data selection, we have to take the characteristics of the data and should predict the target. That is called feature engineering. Feature engineering is the process of extracting features from raw data to enable the application of algorithms. So in feature engineering, we are going to extract the features from raw data to enable the application of algorithms. I will give you an example for this. If you consider an blood report, in blood report we have a type of blood and blood cholesterol and group of blood. These are the raw data. We are extracting that features. The features of this blood is thickness, viscosity. These are the features. So this is an example for feature engineering. It is crucial to the whole machine learning model and sometimes determine the upper limit of this performance. So it is a little difficult in the machine learning model. Manual feature engineering necessitates more labor and computational resources. Deep learning has recently eliminated the need for manual feature engineering, which may become trend in machine learning for material science. In manual engineering process, we need a labor and computational resources and all. But if you take in deep learning process, the labor is not required. It is not much expensive also. So it has a more advantage in this feature engineering. Characterization of materials. Characterization is a critical step in material science. It refers to the general process of probing and measuring the structure and properties of material. In this, we are going to measure the structure and properties of that material. For example, if you take a ceramic or a brick piece, we are going to measure the structure and properties of the brick. The material properties such as strength, toughness, hardness, brittleness, or ductility can be used to classify a material. In material science, researchers rely on experiments and simulation to characterize material. We use some simulation softwares and all to characterize these materials. Historically, characterization of raw or processed materials was done primarily through laboratory experiments, which can be costly. Computational models and high fidelity simulations have made the process more efficient in recent years. The use of ML approaches is thought to be beneficial for the easier generation of material property information to accelerate material characterization. ML methods are trained on experimental datasets. Benefits of machine learning. Machine learning is widely used in many aspects of material science, including new material discovery, material property detection, material prediction, material design, inverse design, corrosion detection, material scanning, and data preprocessing, that is, data collecting and data cleaning. ML can be used to predict appropriateness of new compounds. One significant advantage of using ML approaches is that no mathematical model is required at first. They have evolved into effective tools for analyzing materials in the emerging field of material discovery. They can be used in material discovery applications such as data processing, feature engineering, and machine learning algorithms. ML tools offer numerous opportunities for identifying fundamental interrelationships within material for characterization. The final step is conclusion. The commonly used traditional trial and error approaches rely on personal experience and do not apply for new materials due to their long development cycles, low efficiency, and high cost. So the manual experiment is not used much because it has low efficiency and it is high cost and it takes more time. Exploration of new materials using machine learning is becoming more popular. Various machine learning methods have been successfully used to predict material properties. So we are innovating new things in present day world to predict these material properties. Thank you, one and all.